Give her a round of applause. Here is Daniela.
So thank you for the introduction. I'm glad that we all got a break. We all got cookies, so we have full of energies, yeah? So we can start our journey. Yes? It's going to be fun. Yeah. Thank you to Garrett. I also have a new addition to my talk. I promise, if you don't throw it to me, I will not throw it to you. I will just use it to point people out. So don't be scared. This is a safe place. We're here to learn.
Code of conduct.
Code of conduct. Police is over there checking on us. So let's start our journey. So first of all, why am I here? I'm here because I was a Java developer once, and I was happy, right? And suddenly, I discovered Scala, and I wasn't happy anymore. So I started learning this new language, and my background was basically Gang of 4 on my desk all the time, looking at it all the time, and suddenly I started working with Scala, and people were like, yeah, Gang of 4, forget about it. It's old school. We don't do that thing anymore. So it was a little bit of a shock, because all the things that I learned at uni were basically useless. And everybody was talking about this functional programming that at the beginning, when I started doing Scala, it was 2003. There weren't so many sources to learn how to do Scala in a functional programming way. It was a disaster. It's a great process, so I'm really happy that I went through it. But I'm going to be honest, it was painful. I'm not a mathematician. I don't understand a lot of things that functional programmers used to speak about. Now I went back to school. I know a little bit more. So I'm definitely happier now. But if you are in the place where it was a couple of years ago, don't worry. It will get better, and it's going to be awesome. So because of that, I'm not a mathematician. I don't like crazy words. I am not going to use intentionally any functional programming word, right? So this is a safe place. And you will see that hopefully you will get the idea, even if I don't use any crazy word. Yeah? Cool? Good plan? OK, let's start our journey. So why do I want to talk to you about data validation? Well, the reason why I want to talk to you about data validation because everybody has to do it. There is a really, really high chance that as soon as you receive some data, you will have to somehow validate it. There are two types of validations that I consider in my mind. You have what I call the business validation that are related to the context of whatever you're doing. And the technical validation, things like, can a user perform this operation? Is this a valid email? And things like that. And it can become really, really, really messy really, really quickly. And in particular, the business validation changes every day. And so we need to structure it in a way that is maintainable. At the same time, this is something that everybody has to do, right? So we don't want to reinvent the wheel over and over again. We could, but what we want to do actually is to focus on the new challenging bits of our project. We don't want to solve the same problems over and over again. So our goal is to find a way to validate data without going crazy and reinventing the wheel every time. So now, because this is a beginner's talk, I promise I'm going to be super quick. We will review the key players of our game. Yeah? Cool. So map. What is map? Map is something that allows you to see what's inside a container. So for example, if you have a sum of Daniela, you map it. If the value exists, you add a yo. So in this case, sum Daniela map add a yo, return sum yo Daniela. Yeah? And if you have a container that is empty, nothing happens. Yeah? Next, what happens if in your map, that thing over there, you have a function that returns a container by itself? What would happen is that your return type would maybe contain a value. That's stupid. We just want to say that we may have a value. So there is a magic operation that is called flatten that basically gets rid of one container. And this operation is so common that there is an alias that is called flatMap that basically combines the two. The behavior is the same, yeah? And if you have a map, a flat map, then we have this beautiful syntactic sugar that allows us to chain operations together. So for example, here we have a sum of 1 that gets extracted. So A will contain 1, B that will contain a 5, and then we combine them together, we get a sum of 6. What happens if one of the values doesn't exist? The chain stops. So the whole result is broken. In this case, it's none. Yeah? All good so far? Everyone with me, right? We know this stuff, right? Cool. Then let's start our game. So our game today is going to be called What's Wrong with My Code? And our case study is going to be implementing a function that represents this beautiful form. By the way, this is the proof that I can do front-end as well. So we have this beautiful form that contains an email, a phone number, and we want to submit them, right? So we just started with Scala. We are not cool kids yet. So we don't even know that Scala 2.11 is not the latest version. But it's fine. We will get there. We will become cool kids. So, you know, we start with 2.11. What do? We come from the Java world, so we know option, right, is kind of the same in a way. So we go for it. So this is the definition of what an option is in the package Scala. And it basically has two possible implementations, some that contains a value, or a none that contains nothing. And we have a map, meaning that we can easily look inside what's our option, what's the value inside our option. And we have a flat map that allows us to write the full comprehension, so to chain all the values together. Just to be super clear, this is how we create an option. Easy, right? We know this stuff. Cool. And then let's start our first round. So we have a case class that is called data. That has an email that is a string and a phone number that is a string. And we have a function that is called ValidatedEmail that takes a string and then returns an option of a string. Same with phone. And then we have a beautiful function that is called ValidateData that takes our case class data, and then with a phone comprehension, we validate the email, we validate the phone, and then we wrap them into a case class again for no reason. But, OK. So what's wrong with this code? Please don't say everything. It's just the first round. Be nice. So what is wrong with this code? Yes?
No error messages.
No error messages. Yes? It's cool. I want something a little bit more precise than that. Anyone else? So can anyone tell me, just by looking at the output of the function, what actually went wrong? So if we use the function, if both the values are OK, we return the case class back. That's cool. If both the values are wrong, we return none. If just the phone is wrong, we return none. If just the email is wrong, we return none. So basically, if everything is OK, we return the data. If something is wrong, we just say none. Any problem with that?
No feedback.
Sorry, say again?
No feedback.
No feedback. Yes, we have a winner. We have no clue what's going on, why our function failed, right? It's basically the same of saying, is it valid yes, is it valid no, right? So we are just there. We don't know what's going on, right? And if a straight answer, yes is valid, no is not valid, is all you need, don't use option, just use Boolean, right? What we want to do here is, as the great guy just said, we want to provide some feedback. We want to tell exactly why the data is not cool, okay? So don't use option. Come on, guys. Option is great. We love it. We know what option is because we come from Java. But don't use it for validation, okay? We have all done it. I've done it. The early days, I've done it. And I'm ashamed of it. So don't do it. Cool. So second round. Option is not quite what we are looking for, right? So we look around and we discovered that in Scala 2.11 we have something else that is called either. This is the definition of either, lives in scala.util, and has two possible implementations, left that contains a value, and right that contains another value. We don't have a map, so we cannot easily look inside and see which one, if we got a left or a right, and we don't have a flat map. So we cannot write a full comprehension. Again, this is 2.11, okay? What we have instead of having a map and a flat map is something a little bit weird that kind of works, but yet you basically have to say which side you want to map on. So you have to say, okay, use the last projection, meaning that I want to map and flat map on the left side, or use the right projection, meaning I want to map and flat map on the right side. So it's our choice. We have to tell it. If we don't pick a side, we basically cannot do anything with either. This is how you build either. It's basically the same as an option. It's just this bit is different, and this bit is different. So nothing too crazy, right? Yeah? You guys ready for the next round? Yay, okay. So we have a case class that is called data that has an email that is a string and a phone that is a string. We have a beautiful function that is called ValidatedEmail that takes a string and returns either a list of strings or a string. Note, a string because multiple things can go wrong with an email, right? We want to be specific on what went wrong. Same for phone, and then we have this beautiful function, validate data, that takes our case class, that returns an either of a list of string or the data. So we validate the email, we validate the phone, and then what we do is that we pattern match on them. So if the email was right and the phone was right, we wrap everything in right of data. If the email was wrong and the phone was wrong, we wrap everything into a left with all the errors. If just the email was wrong and the other one, who cares? We just return the email one, same for the phone. What's wrong with this code? Yes?
It's not very nice.
It's not very nice. I like that one very much. So this is crazy. It works. But can you believe what happens if now your manager asks, actually now we have that third thing to validate. The combination will be, help me out, 8 combinations? What happens if now it's 4? And what happens if it's 20 of them? You will probably go crazy, right? This is really prone to errors. We don't want to live with stuff like this. Again, it works. But it's terrible, right? Anything else that is wrong with this code? No? Okay, I'll tell you then. So as we were saying before, the function itself works, but it's terrible to maintain. The other problem is who is telling us that right is the right value, meaning the correct value, and left is the wrong one? English helps a lot here because right is right and left is wrong. But believe me, I've been living in the UK for 7 years, and they still drive on the wrong side of the road. So you will always have someone in your team that is saying, actually, the correct value should be on the left, right? So it's not great to have this arbitrary decision of what's wrong, what is right. We just want the compiler to enforce one way rather than the other. The way the cool kids say this is that either is not biased. It means that it's the developer that chooses which side we want to map on. And as we were saying before, the code is just crazy. I mean, it works, but good luck to anyone that has to maintain it. Cool, then we speak to our cool kids friends, and they tell us, no, but cool kids these days don't use 2.11 anymore. We have 2.12 now. Show of hands who is using 2.12 in production. Yay, we have probably a third of the room. The other rest of the room, please upgrade as soon as possible. Please do upgrade. So a few things have changed in Scala 2.12, but the thing that it's interesting for us is that in 2.12, either is, we say that either is right biased. It's the same as before, the package is the same. You have either that has two possible implementation, left of a value or right of a value. But now we do have a map, and we do have a flat map. What basically they have realized is that there wasn't much that we could do with either. So they just have decided, unless you tell me otherwise, I will always assume that right is right. So by default, they will just map on the right side. You still have the projections, but now you are not forced to specify which projections to use. The way you build either is exactly the same. Okay? Yeah? Ready for the next round? Yeah, let's go. So you have a case class that is called data, that has an email and a phone. Then we have a function that has validate email that takes a string and returns an either, a list or string, same for phone. And then we have a beautiful function, validate data. And because now we have a map and a flat map, we can actually write a nice for comprehension. So we validate the email, we validate the phone, and we combine them together. So what's wrong with my code? Okay, sorry, I beat you on that one. Yes, it fails too fast. That is exactly the expression that the cool kids are using. What this means is that if I pass two values that are okay, it works. But if I pass two values that are both wrong, it will just return the first one. The reason why this is happening is because it will evaluate this one, it will see that it's broken, and it will not bother to look at the second one, right? And that is not exactly what we want to do. Let me be crystal clear on what I mean with that. I believe that functions should behave in a reasonable way. What we are saying here is that let's assume that we have a beautiful form like this, right? And we have put 3 bad values in. What this function is doing is that if we submit the function, it will say, the first one is wrong. Okay, so we change just the first one because that's the one that we got feedback on. And we submit it again, and now it's saying, yeah, now it's the second value that is wrong. Then we change it again, and now it's the third value that is wrong. So I would be personally really upset by a website that works like this. What we actually want is to, given this form, tell me everything that is wrong so that I can move on with my life and get over with it, right? And this is exactly what we want to achieve with our function. So either is not quite right for our task. So it's cool as long as you don't have to accumulate errors. But as soon as you have to accumulate errors, it doesn't work anymore. So if you are confident there is only one thing that can go wrong, and I kind of envy you guys, because in the applications that I write, there are millions of things that can go wrong, either is fine. But it's actually not quite right for our problem. So we had an overview of the things that the language offers by itself, and we couldn't find anything that actually suits our need completely. So let's have a look around at a library that is called CATS. CATS, Miles, that is the main author of this library, is actually not a cat lover. He's actually a dog lover. It's called CATS because it's based on category theory. Don't worry, we're not going to talk about category theory. But let's see a little bit how CATS can help us solve our little problem. So good. If you're stuck to 211, CATS will give you this magic import that will make your either right bias by default. So if for some mysterious reason you cannot upgrade yet, but you want to use either in a right bias way, you can still do it. If you are familiar with CATS, that was basically called XOR, but then they realized that was basically the same once they introduced the right bias either in 212, so they decided to remove it. Okay, so let's have a look at CATS. CATS has this data type that lives in cats.data that is called validated. It has two possible implementations: valid, that contains a value, or invalid, that contains another value. That's cool. At least now there's not going to be discussion on what is right and what is wrong, right? Wording is pretty clear on what is what. So that's a step forward. And then we have a map. It means that we can easily open the container and see what's inside. We don't have a flat map. And that is actually a good thing, because we have seen that we want to forbid people from writing a full comprehension, because that doesn't work with what we want to do. But we have something else that is really, really, really useful for our case study. And this something else is called apply. Now, I don't want to break my promise. I'm not going to use any crazy words. So if you are brave, there is a beautiful link here that is going to explain you exactly what apply is. By the way, all the slides will be online, so the code, so don't worry. If you want to take pictures, you are more welcome to, but they're going to be online, so don't worry. But basically, what apply does is that adds this crazy symbol to our container that does exactly what we were doing with the pattern matching. Meaning, it will go through all the instances, check if any of them failed, collect all the failures, and if there were no failures, it will just apply a function to all the successful values. Yeah? This symbol has a crazy name. A guy in the US told me that it's called the Cinnabon symbol. Other people told me that it's called the TIE fighter symbol. I'm Italian, so for the purpose of the presentation, I'm going to call it the pizza symbol. If you click this link, you will discover the real name. So please, don't Google pizza symbol. You're not going to find an answer. Come and find me. I will tell you all the real names so you guys can Google things, but don't Google pizza symbol. Well, you could, but you're not going to find an answer to this problem. How do we build a validated? It's very similar to what we have seen so far, right? So if you have a good value, you just call valid. Otherwise, you call invalid. Or if you want, cats uses some what we call smart constructors, are just functions that basically do the same thing. The difference, what's the difference? The imports. So here we have two imports. If you don't like to import all this stuff, you can just do one import and do this. It's up to you guys, whatever you like. Okay? So ready for our next round? Okay, yes. Ready for our next round. So we have a case class that is called data that has an email and a phone. We have a function that is called ValidatedEmail that takes a string and returns a validated of list or string or string. Then we have the same with phone. And then we have a function that is called ValidatedData that takes the case class. And then we validate the email, validate the phone, and then pizza symbol. And we use it, and the pizza symbol will just accumulate all the invalid instances. And if there are no, not accumulate, it will combine all the invalid instances, and if there are any, it will extract all the valid piece of information and apply a function to it. Yeah? So what's wrong with this code? Well, my code. Yes?
Well, it's not explicit how the aggregation actually happens.
It's not explicit how the aggregation actually happens. No, it is because of the definition of the symbol. There is a semigroup defined. Oops, I said a forbidden word. There is something defined that tells you how to combine things, but we can have a chat about it later. Next. No idea? Yes?
You can end up with an empty list.
Yes. What happens if, can you return an invalid of an empty list? Yes, you can. It's like saying, do this wrong, but I'm not going to tell you why. Right? We want to forbid people from doing that. This code works, don't get me wrong. This works. So if you have an OK email, OK phone, and then you pass, you get the case class. If you pass both the values that are bad, you get both the errors. So this is a good solution. What we are looking now is little details that can make our solution even better. So what was suggested by the audience is that we want to forbid people to return valid of an empty list. So if it's invalid, I want the compiler to guarantee there is going to be at least one reason why my data is invalid. Okay? And turns out that this exists. Mice thought of everything. So there is this little thing that is called validated nil, where nil stands for not empty list. Lives in castle data, and not empty list is just an alias for this type. There is one and a collection. And validated nil is just an alias for validated that contains, rather than just a simple list, a not empty list. Yeah? Everyone with me so far? Yes. Cool. Anything else that we don't like about this code? This is a tough one, so don't worry if you don't get it.
At the end, I don't know which fields to mark.
At the end, I don't know which fields to mark. Sorry?
To mark as invalid. I only have the string saying
yes.
wrong, but I don't know.
So we have a string that tells us what's wrong, but we don't have any extra information. Well done yourself. That was a tough one. Yes. So what's wrong with this code? We represent the error as a string. A string really doesn't have any structure. We want to have an error that gives us, that has any structure, that tells us some information, like, for example, which field went wrong, or what code we should use for these errors so that we can do some pattern matching later, or maybe a human explanation of why this information was wrong. So this is how you can, I skipped a little bit ahead. I do apologize. So this is how you create a validated nil. It's basically the same as before. You do have a smart constructor. And then what I was saying before, representing the error as a string is not cool. The reason why it's not cool, because we probably want to do something with this error. So we want to have something with some structure. This is just one example of what we could do. The message that I want to pass here is whatever you pick, it's fine, as long as it has some structure. So this could be one option, is to represent our error with a case class that has an error code that maybe can be used by the consumer of our API or whatever to do some pattern matching, and a message that helps our poor developers that have to figure out why the data was rejected. So this is our final solution. We have a case class data that has an email and a phone. Then we have a function that is called validated email, that's a string. And we return a validated nil of an error, that is the case class that we created, or a string, same with phone. And then we have this function that is called validate data that takes a case class and then returns a validate nil of an error or a data, and we validate the email, we validate the phone, pizza symbol to the rescue, and we combined, either we combine the errors or we extract all the valid values and we put them into a case class. So what's wrong with this code? Okay, just kidding, this works, it's fine, it's beautiful. If you guys have any idea on how to improve it, it would be awesome. Yes?
If I had an Uber form and I had more than 22 fields, and I couldn't use my big symbol anymore, right?
So what happens if I have more than 22 symbols? Currently, in CATS, you will be in trouble. Code of Conduct is watching us. You will be in trouble. Yes, it's true. So adding new fields is not going to be a problem. You just put more pizza symbols. But obviously, there is a limitation currently in Scala where with things with more than 22 parameters, we don't go that far. There are solutions. So you can use function composition to help you out. But yes, it's not really a solution. You just, instead of validating 22 fields together, you first validate 10, and then you validate 10, and then you validate 10, and then combine everything together. But yes, that is actually a limitation. Cool. And just so that you guys can trust me, this works. So if we pass both the values that are OK, we get the case class back. If we pass both the values that are wrong, we get both the errors. So that's cool. And if we pass just one value that is wrong, we just get the one that is wrong. OK? So basically, what this pizza symbol does is that instead of validating things in sequence, like in the full comprehension, it validates our values in parallel. Note is written on a single line, while the full comprehension is written into multiple lines. Yeah? And turns out that this pizza symbol is actually quite useful. And you can use it for things rather than option. So it has a rule of thumb. It's not always true, but it has a rule of thumb. Every time you can write a full comprehension, you can also use the pizza symbol. What's the difference? In this example, we will compute asynchronously this future. So we will start this future, wait for it to finish it.
we will get 1. Then we will start this at the future, wait for it to finish it, and then get a 2. Then we will start this at the future, get a 3, and combine all of them together. So we start all the futures in parallel. But actually, what happens is that because these futures are independent, with the pizza symbol, we can just start them all of them together at the same time, and then combine them as soon as they're finished. So it's basically sequential computation with full comprehension and parallel computation with the pizza symbol. Yeah? So this is basically the slide to remember. Yeah? So pizza symbol is super cool. Awesome. So we have done this little game. That it was fun. But thank you, we don't write forms with just 2 fields, right? We do things that are a lot more complex than this. So how do we translate the things that we have learned with our game into our application? So these are my advice on how to translate all of this in your project. So the first advice that I want to give you is, the first thing to do is decide how you want to represent your error and stick to it. Don't start representing the errors in 20 different ways. Just pick one, and that's it. The reason why I'm saying this is because we are probably going to accumulate a lot of errors from different parts of the application. And accumulating errors that are the same, it's easy. Accumulating things that are different, it's a mess. Okay? The second advice is that because we want to make sure that everyone is using the same error type, use an alias, right? Alias are awesome. So whatever you decide your error to be, just tell to your team that the function needs to return this validation type. This way, the compiler will guarantee that only one error representation will be used. The third step is probably the more important, is know your team. I personally work with people with different backgrounds, so I work with people that comes from the Ruby world, from the Python world. I don't like the crazy pizza symbol. I love it, but they don't. So what we have done is that we basically renamed the pizza symbol with a more expressive name, and we have done that with a companion object. So that for us, it's really easy to create instances of this validation without actually know what an empty list is or any details that the team doesn't need to know unless they really want to know what it is. So make them simple for them, because otherwise, obviously, they're not going to do it. They're not going to use the rules that you impose on them. So this is a concrete example from work. It's simplified, but it gives you an idea of what kind of things you can do with this. So this is our representation of an error. There is a trait, seal trait, that has a code, there is a string, that is used by the consumers of our API to do whatever they want to do. We don't care. This is a message that is meant for the developers so they can understand exactly what's going on. And these are the list of all the values that trigger the validation, if any. And then we have case classes that extend this trait. So for example, we have a bad request that has a code and a string and always values empty, and a case class that is called not found. So basically, this is behind an API. What we do is that if there are errors, we look at all the errors, and if there is any bad request error, the status of the API is going to be 400. Otherwise, it's going to be 404. So it's the error that dictates the return status code of our API. And this works really well for us. So the first step was to pick an arrow representation. I just showed you an example. The second step was to create an alias. That's basically what we have done. And to make it extremely easy for the team to use. So what we have done is that in the companion object, we have a function that is called success that takes a value and returns a validation of t. So people that want to create an instance of this validation, they just do validation.success, and they pass the value. And for failure, we have the same. So when they want to create a failure, they just do validation.failure, and they pass the error. Note, they're completely unaware of the fact that they're using a not empty list. The companion object hides all this complexity from them. And this is how we rename the pizza symbol. We just created a function that is called accumulate, because they liked it more. And yeah, it worked really well. So to summarize our journey, do not reinvent the wheel. There are common tasks that every one of us has to do. Try to reuse libraries that are out there, because there is a really good chance they have better implemented and tested what you could write. Focus on the things that are actually new and interesting on your project. Always when you have an error, or in general when you are thinking about your functions, use an expressive type. Using the right type for your problem actually helps you a lot. I would say if you pick the right type to represent whatever you are representing, it's 0.5% of the job done. So take your time, think about it. It will take some time, but you'll get it. Doing examples like this, really simple representation of the problems, do help along. And also be aware of your team, right? So if needed, obviously, library authors cannot do this, but if your code is specific to just a certain type of applications, don't be afraid of customizing the solution and writing a DSL or companion object functions on top of what you already have. So, as I was saying before, the best way of learning is just to code. So, you can find all the code that I've shown you today on GitHub. My suggestion is to just go there, fork the repo, and just convince yourself that it works, or it doesn't work, depending on what you're looking at. I'm going to post all the slides, so just follow me, and you will find these beautiful slides online. And if you want, have a look at my blog, and that is me. Thank you. Any questions? Okay, then in that case, a reminder for Goretz. We will have a coffee break where the winner of the beautiful ruffles is going to be revealed. So don't forget to stand at the stage right in front of the coffee table, because the ruffles are awesome, and the prize is awesome, and the winner is going to be really happy. Okay? Thank you, guys.